This video I'll be discussing how the overdrive solenoid works, as well as I'm doing a full report on what caused the problem and how to diagnose it and how to repair it. So different to most, if not all, car shops, auto repair shops. I actually go through the entire process of determining exactly what happened and how I can prevent the same problem from happening again. So most shops will just find whatever part you have that's faulty, they'll just replace it, put another one in. That has a few problems because sometimes you're just throwing money away and then things just keep breaking down again. And like I said, I want things that are durable. And the laws of physics state that in order to change the state of something, whatever the state is, be it movement, be it temperature, there has to be an external force. Nothing changes itself by itself. So for something to, for rust to form, for something to happen in the car, there has to be some external force, something that's causing that to happen. Things don't just rust by themselves. So although you might think that is the case, it's not, because water and salt are usually what causes rust. In an environment where there's no humidity, rust will not form. In an environment where there's no salt, pretty much rust will not form. So there is something that's happening that's causing a problem. Something is had to happen to cause this relay to stop working. Something had to happen to cause a seal to fail, right? Or some gasket to leak. Something had to happen for that, for you to get that problem. So that's the way I run things here. So first off, if you read about the solenoid, you'll find that the manual says that there are you actually have to get a manual for the solenoid. Just the manual on the car does not usually cover the workings of the solenoid. But it is fairly simple, and there are two coils of wire here, and a coil of wire forms an electromagnet. So when that electromagnet pulls that out like that, so this shaft here moves out, and then it moves back in against by this spring here. So I'm compressing the spring, right? And the reason there are two solenoids is, again, laws of physics. If you study physics, you need a larger amount of force to move something from a state of non-movement. So it's called a static force. So right now this solenoid is not moving, or whatever object. You need a greater amount of force to start it moving, to from 0 to whatever speed. Then you need more force for that than you need to keep it moving, right? So basically, you need a lot more energy to move a piano that's stopped than to keep it moving. So if that piano is already moving, even if it's very slowly, you don't need as much force to keep it moving or to accelerate it. So that being said, you need a hell of a lot of energy, a lot of electrical magnetic force to move this shaft that way against the spring. And then once it's already there, you don't need that much force to hold it there. So there's a pull-in coil and there's a hold-in coil, or a pull-in coil and a holding coil. So the pull-in coil, it does what the name suggests. It pulls the shaft in that way. And then it's supposed to turn off, and the hold-in coil just holds the shaft there. you need quite a bit of force for this. Right, so the Holden coil, it works only momentarily. Sorry, the pull-in coil works only momentarily. When this reaches there, then it's turned off and the Holden coil takes over. So right here, and then of course all these things are connected to how you find these terminals. So let's say right now there's no markings on the housing. There's the cap there. There's not really any markings there. Some of them come labeled with A or R, something like that. But so how do I know which terminals are which here? So as you can see, this terminal is just connected to this top shaft here. It's not connected to anything else. So that means that this here depends on this here. And this terminal, the one closer to the shaft, as you can see, there are wires going to it. 2 wires in this case. And that terminal, let me try to zoom in there, is isolated. It's insulated. You can see there's like a you can see the insulation there. And both wires, there's a thick wire and there's a thin wire. And the thick wire goes to the pull-in coil, which is a stronger one, and the thin wire goes to the Holden coil. And how do I know that? From looking at the other side. So where are the other terminals? So again, basics of electricity. You need 2 wires to power anything. So we should have another 2 wires. And sure enough, there's 1 wire, there's a thin wire there. And as you can see, the thin wire is connected directly to the body. It's soldered onto the body of the solenoid. So the solenoid is connected to the car, which is ground. So this is ground, and in most cases it's negative ground. So this here is negative, which implies that the other terminal that I just showed you is positive. And as you can see, now the other wire, the thick wire, it goes to the set of contact points. Now, so the way this works, again, is you power up the solenoid, and you can read this directly from the manual. You power up the solenoid. When you first send electricity to it, both these coils are supposed to turn on so you can get the maximum force. And then basically at the end, when the shaft is extended, you turn off the bigger coil so that you don't have to use up as much electricity, as much amperage. And so let me try to show you the other wire. Right, yes, there it is. So if I zoom in there, on the left you can see there's the thin wire there soldered onto the housing. And then on the right you can see the thicker wire there. And the thicker wire goes to this contact points here. So if these contact points are open, as they are now, give it a second for it to zoom in. As you can see, they are open now. Then electricity will not go to the thicker coil, which is the Holden coil. And how do I know the thicker wire is the Holden or the pull-in coil? Sorry, the pull-in coil. Because this one, the terminal of the thin wire, is connected directly to the negative. And the other terminal is connected directly to the positive, which means as long as we have positive going into this terminal, this thin wired coil will be permanently on. There's no way to turn it off. On the other hand, the thick coil is connected to these set of contact points here. So it is possible to turn it off. And what turns it off is the movement, the downward movement of this plunger here, this core. And as you can see, there's a tab there. And that tab hits, I'm going to try to do this with one hand here. And that tab, when the electromagnet moves downward, it pushes on that tab and disconnects the contact points. It's going to be hard for me to show it to you. Let's see, maybe with my right hand over here. One second. It's just touching now. There. Hopefully you can see that. So again, when the core or the plunger reaches its maximum extent, it turns off the negative terminal, the ground terminal. As you can see, the other end of this contact point is connected to ground. It's again connected directly to the body of the solenoid right there. So disconnecting it interrupts the flow of current. Now, you know, a lot of people just chuck one of these things away and say, oh, you need a new one. Sometimes I do that because sometimes I know, I do that when I already know what the problem is. It's not viable to solve it or fix it. It's just cheaper and easier to repair it. But in this case, this solenoid here costs over $300. So if I can fix it and prevent it from being damaged again, then that will save me a lot of money and pain in the ass. Now, if this stops working, it's not a huge deal because you just don't have overdrive. You can still just drive the car normally, right? And I'll go into the problems in the next video, or depending on how much time I'll stay in this video. I'll just do it in the next. So I think I pretty much covered how this works. This other switch, it's used for something else that I'm not using at the moment, and most of you probably will not be using it either. But so I'll mention that in the next video. But this is how you determine, the workings of it. So basically, when I connected the battery charger, you can watch this on the previous video, you'll notice that the circuit breaker on the battery charger did not fall, did not trip or break. So that tells me that this is not short-circuited. If there was a short circuit in here, then that battery charger circuit breaker would have tripped. But instead, it showed a steady charge of 2 amps. So that immediately suggests to me that it's using something here is using 2 amps. And if you follow the circuit, you will find that only the thin-wired coil, or the Holden coil, is connected, and that's why it's being used. That's why it's using only 2 amps. And this one, the big coil, is not operating because of that gap there. And as you can see, that's our problem there. So as you can see, that heated up and it almost melted it, made a hole. And the heat caused this spring, you can see it's a spring, to move apart from the contact points, thereby disconnecting. So this here is pretty neat. It works as a fuse. I don't know if that was the intention of the manufacturers or it just happened to be that way, but it used up a lot of amperage, and the amperage melted, the electricity melted this. It didn't melt it all the way, just made a hole, and then the heat warped it and disconnected it. So it kills itself just like a fuse. Except fortunately this here isn't completely bent and it's not completely melted off. Otherwise I would have to stick another tab here. Now, so it's very easy to test this again. Electricity usually comes, it gets its negative ground from here. If I just bypass this and connect the negative directly to the wire, then it should work. And that's what I'm going to do right now. So let's connect our positive here. Connect both of them together, yes. So what's happening now is I can't use the battery charger because it only goes up to about 8 amps. But if I connect this to the battery of the car, then it should work. So the manual says that this is actually a 30 amp. It uses 30 amps on the pull-in coil. So I'm connecting it to the battery now. Battery should have enough amperage to turn this on. As you can see, it turns on just fine. So as you can see, although the solenoid is not working per se, I've just saved myself a lot of dollars and time by noticing that the problem is this tab here. So I could possibly replace this, or I could also drill a hole on it and attach a spring from here to there to keep it close to that set of contact points. And I might also do that. But I'll try to just bend it first, just rebend it. So that this is reconnected there. And the set of contact points are closed together again. So that's pretty much how this works and how I repaired it. And then on the next video, I'll talk about how and why this happened, and yeah. So hope this helps somebody out there saving money on your solenoid.